Hello everyone. I welcome you all again in the journey of mathematics learning. In the previous classes, we have solved the problems from the chapters, polynomials, especially from the algebra section, pair of linear equations that we have completed. Now here we are here to solve the problems from the chapter quadratic equation. So you know that the quadratic equation means it is an equation whose degree is 2. Degree means the highest power of the variable. If the highest power of the variable of an equation is 2, then we used to say that that equation is a quadratic equation. You can see here on the board an equation having degree 2 as quadratic equation. For example, you can say that x square minus 5x plus 6 is equals to 0. Remember that in case of equation, that is equal to sign should be there, and the objects should be compared clearly. That we used to say the equation. Now next thing, in the previous classes in the chapters polynomials, we try to find it out the zeros of the polynomial, and we obtained it also, and we have seen the relationship between zeros and the coefficients of the roots zeros there in the polynomials. Now here, you know that this is the standard form of quadratic equation. There you can see that highest degree term x square is there, and degree 1 term linear part bx is also there, and the constant part is also there, and it is compared with a is equal to sign. So this is a standard form of quadratic equation. Remember, it is written here that a is not equals to 0. It means that what happens if a is equals to 0? I already have explained this. Once if the value of a is 0, this whole part becomes 0. So this section only represents the linear. That's why a should not be 0. Now what are that a, b and c? Here a, b, c are constant, real numbers, where a should not be equals to 0. Now we'll talk about the number of zeros. Number of zeros in case of polynomials. But listen one thing. In case of polynomial, the value or values of the variable which makes the polynomial 0 is known as the zeros of the polynomial. But in case of equations, which actually the meanings are similar to each other, here we used to say the word roots. Roots means value or values of the variable or variables of an equation which satisfies the given equation. For example, x square minus 4 is equals to 0. This is a quadratic equation. What are the possible values of x here? The possible values of x are, one of the value is 2. Just verify it. 2 square minus 4. This is 4 minus 4, which gives us 0. So we have started from left hand side and we are getting the right hand side. It means that this x is equals to 2 is one of the root of this quadratic equation. X square minus 4 is equals to 0. Now we have said that in case of quadratic equation, the number of roots are 2. But we have seen that x is equals to 2 has already satisfied this equation. Do we have any other value that satisfies this equation? So for that, just take it out that x is equals to minus 2. That means in place of x, just put it this value of x as minus 2. Look at here the left hand side. It gives us x square minus 4. In place of x, just put it there minus 2 whole square minus 4. It gives us 4 minus 4. Again we are getting the right hand side, that is equals to 0. It means that this x is equals to minus 2 is also another root of the quadratic equation. Do you know what is the type of the quadratic equation that we have written here, which is not exactly in the form of the standard form? So these are actually adfacted quadratic equations. So in case of quadratic equations, the number of roots are 2. Now how to find the roots? There are some methods, out of which one of the method is factorization, which includes middle term splitting, completing the squares, completing the cubes. And another you can see here, Sridharacharya formula, that is quadratic formula, famously known as quadratic formula, right? So we already have discussed about this factorization to find the roots. Now today we are going to discuss about this Sridharacharya formula. So first I'll write it on one equation, quadratic equation. Let it be x square minus 2x minus 3 is equals to 0. First, we will find it out, its roots using factorization. So for factorization, we'll take that middle term splitting. X square minus this 2 should be split into two parts. So the factors of the numbers that we have in the first and the last term is 1 and 3. It gives us product 3, and 3 has the pair of factors as 3 and 1. So we can write 3 minus 1. Minus is coming here because the product of the sign of the first and the last term will give us the sign that we are putting here in between these two numbers. So it gives us x square minus 3x plus x minus 3 is equals to 0. Take x as common, x minus 3. From these two, take 1 as common, you will be getting that x minus 3, that is equals to 0. So x minus 3 multiplied with x plus 1 is equals to 0, because in these two terms, you can see in these two terms, x minus 3, that term is common. So we are keeping that in one of the bracket and the remaining in the another bracket. And we have already known about it, that the product of two numbers are 0. If the product of two numbers are 0, then one of the number must be 0. Otherwise, we can have both the numbers should be 0. So we'll be writing here either x minus 3 is equals to 0 or x plus 1 is equals to 0. So from here you can see that the value of x is 3, and from here the value of x is minus 1. So it also verifies that the quadratic equation has exactly two roots. So here you can see that the quadratic equation x square minus 2x minus 3 has two roots, that is 3 and minus 1. Now what is another method, that is Sridharacharya method or quadratic formula, which helps us to find it out the roots of the quadratic equations. So Sridharacharya formula or quadratic formula says ax square plus bx plus c is equals to 0, where a should not be equals to 0, be a quadratic equation. Then the roots of this equation is given by minus b plus minus square root d whole divided by 2a, where that d is discriminant, which is actually b square minus 4ac. Why that b square minus 4ac is known as discriminant? Because the nature of the roots of quadratic equation is totally dependent upon this value, that b square minus 4ac. Now how this d, the value of d, decides the nature of the roots of a quadratic equation? So first of all, we will say this one. The formula is x is equals to minus b plus minus, if we can write this as b square minus 4ac, it's better, 2a, just we are rewriting that d as b square minus 4ac. Suppose if b square minus 4ac, that is inside the square root, its value is suppose 4, that means the value of d is 4, then square root of 4 will give us 2, and that 2 belongs to the set of real number. That means 2 is real number. But if you have b square minus 4ac is equals to minus 4. If b square minus 4ac is 4, that is the value of d, then square root of 4 is 2, that belongs to the real number. But instead of 4, if we have minus 4 in place of b square minus 4ac, that is the value of d as minus 4, then look at here, square root of b square minus 4ac, this is equals to square root of minus 4. Now how much is this? Is it minus 2? No, because minus 2, the square of minus 2 cannot give us minus 4, because negative 1 minus 1 to the power even number is always positive of positive number. So that's why we cannot write it down this is exactly as 2. Then what may be the value of this one? This can be expressed as square root of minus 1 into square root of 4. So square root of 4 is okay, this is 2. But what is the value of square root of minus 1? This gives us idea of imaginary number that belongs to the set of the complex number, which we will be discussing in the higher classes. So this is denoted by iota I. So that's why square root of -4 is 2i, but that does not belongs to the set of real number. That's why the nature of the roots of a quadratic equation is totally dependent upon the value of discriminant. If discriminant is positive, no problem. We have seen here we can get the real roots. If the value of discriminant is 0, that means in place of b square minus 4ac is 0, then also square root of 0 is 0, that also belongs to the real number. We are going to get the real roots. But instead of that, if the value of d is minus negative, then it is not possible to get the real values. That's why I already have told you that b square minus 4ac decides the nature of the roots of a quadratic equation. So first, nature of the roots, you can see here, if b square minus 4ac is equals to 0, that means discriminant is 0, then there exist two real and equal roots, because we know that the formula x is equals to minus b plus minus square root d divided by 2a. If this the value of d is equal to 0, square root of 0 is 0, so the value of x, you can see here, minus b plus minus 0 divided by 2a. So here you can see that the value of x as minus b divided by 2a. But look at here, the degree of this quadratic equation is 2. That's why it is said as a quadratic equation. Here you can see that the value of x we are writing here is only 1. Then what will be the next value? The next value of x will be the same, that is minus b by 2a is one of the value, and another value is also minus b by 2a. So these two are the, by looking into it, the value of a and b as can be substituted using above this the value of abc. We will get these two values, and the value of these two roots are exactly same. So that's why if discriminant is 0 in a quadratic equation, so there exist exactly two equal real roots. So let us take one example. That means where we can find it out, the roots are equal also and discriminant is 0. X square minus 4x plus 4 is equals to 0. So first comparing this equation 1 with you can say that ax square plus bx plus c is equals to 0. So by comparing it, we can say that the value of a is 1, value of b is minus 4, and value of c is 4. So first we will find it out the value of discriminant, that is b square minus 4ac. So this gives us minus 4 whole square minus 4 times 1 into 4. Here 4 4s are 16, minus 4 4s are 16, which is equals to 0. So here we can see that the value of discriminant is 0. Now we will find it out the roots here. We already have learned how to find it out the roots by using factorization. That means middle term splitting. Today we will be learning using this quadratic formula. The value of x is minus b plus minus square root d divided by 2a, and minus how much is the value of b, that is minus 4, plus minus square root of d is 0 divided by 2 multiplied by 1. So this is minus into minus plus 4 plus minus 0 divided by 2. Okay, why there is plus minus in the quadratic formula? You know that in case of, let me first explain this and I'll come back here again. Quadratic equation which should have two roots, that two roots can be obtained by using plus and minus sign. If you use the plus sign, just like this, x is equals to minus b plus square root d divided by 2a. It gives us one of the value, one of the root. If you use minus b minus square root d divided by 2a, you will be getting another root. That's why there is plus minus sign. Now back again to the same. So here 4 plus minus 0 divided by 2, which is equals to 4 divided by 2, plus minus is removed here due to 0. So the value of x we can see here as 2, but being a quadratic equation, it should have exactly 2 roots. That's why another root is also equals to 2. So we have verified here as if discriminant is 0. Look at here, if discriminant is 0, then there exist exactly 2 real roots and the value of that real roots are equal. What I mean to say is that if discriminant is 0, in quadratic equation there exists exactly 2 roots and the value of that roots are equal, and that belongs to the set of the real numbers. Another thing that should be clear to you is if discriminant is 0, then there exist 2 real and equal roots. What if in an equation there exist 2 real and equal roots? Then the value of discriminant will be 0. Remember, if discriminant is 0, this implies there exist 2 real and equal roots. If there exist 2 real and equal roots, then we can say that the value of discriminant is 0. Don't forget this. Now next comes under the nature of the roots. If the value of discriminant is positive, if discriminant is not equals to 0 but positive, then there exist real but unequal roots. Let's verify with one example. X square minus x minus 6 is equals to 0. Remember again, if discriminant is positive, there exists real and unequal roots. If there exist real but unequal roots, then the value of discriminant will be positive. Remember this. Both the sides will be satisfied. So first we will find it out its discriminant. For that, what we need to do? We need to compare this with ax square plus bx plus c is equals to 0. Listen one thing. If you are getting the negative sign in the given quadratic equation, you are not supposed to compare with that ax square minus bx minus c like that, because this is only the standard form of the quadratic equation. You should compare with this only. So look at here, the value of a is 1, value of b is minus 1 and value of c is minus 6. So the value of discriminant, that is b square minus 4ac, this is equals to minus 1 whole square minus 4 times 1 into minus 6. You should be careful with the sign that will be there for all the coefficients. So it gives us 1 minus into minus plus 4 6 are 24, 1 plus 24 is 25, so definitely it is greater than 0. So in this case the discriminant is positive. Now let us check it out. What are the value of roots here? Whether the value of roots are equal or not. So we have seen that the value of discriminant for this problem is 25. So we know that the value of x can be obtained using quadratic formula is minus b plus minus square root d divided by 2a. So this is equals to minus, what is there in place of b? In place of b is minus 1, minus of minus 1 plus minus square root of value of discriminant is 25 whole divided by 2a. Minus 1 into minus, it gives us 1 plus minus square root of 25 is 5 divided by 2 times of value of a is also equals to 1. So 1 plus minus 5 divided by 2, that is the value of x. Now if you'll take the plus sign here, you'll be getting one of the root, that is 1 plus 5 divided by 2 is 6 divided by 2, which is equals to 3. And if you'll take the minus, then you will be getting the another root, that is minus 4 divided by 2, which is equals to minus 2. Look at here, the value of x here are 3 and minus 2. Both are real number but unequal values. Both are real number but unequal values. Now next you can see here, if the value of discriminant is negative, we already have seen there. If the value of discriminant is negative, that means there does not exist any real value. Square root of negative number is not real. It belongs to the set of the complex number where square root of minus 1. Square root of minus 1 is denoted by iota, that is I. So that's why once while solving the problem will be asked just like this: find the roots if exist. For that, for such type of problems, first you have to check for the existence. For checking for the existence, you have to check the value of d. If d is 0, if d is positive, then there exist real roots. But if the value of d is negative, then there does not exist any roots. We don't need to find it out that values, because in the syllabus of class 10, it is not included. So what type of problems will be there where we can see that the discriminant, value of discriminant is negative. Look at here, x square plus 2x plus 6 is equals to 0. By looking into the equations, it is very clear that it can be gone under the factorization, middle term splitting. But first, let us check it out, its discriminant. Here, if you compare this with ax square plus bx plus c is equals to 0, the value of a will be 1, value of b is 2, value of c is equals to 6. So discriminant is b square minus 4ac. This is equals to 2 square minus 4 into 1 into 6. 2 2s are 4, minus 6 4s are 24. 4 minus 24. Is it 20 or minus 20? This is equals to minus 20. So negative, discriminant is negative. It means that square root of minus 20 does not belongs to the real number. So roots does not exist. So if the problem is asked as find the roots if exist, first check the value of discriminant. If you'll get the discriminant is 0 or positive, then after you have to find out the roots. And to find the roots, it's better to use the quadratic formula once you have obtained the value of d. If you have not obtained the value of d, then you can use middle term splitting, will work on it also. But if the value of discriminant is negative, no need to find it out the roots, because the real roots does not exist. That's why no need to find it out. That is not there in our syllabus in class 10. So by combining this nature of the roots, what happens if discriminant is greater than 0 or discriminant is equals to 0? That means if discriminant is greater than or equal to 0, under that case there exist real roots, because you have seen in the first case, you have seen that if discriminant is 0, then there exist real and equal roots. If discriminant is positive, there exist real and unequal roots. If discriminant is negative, there does not exist any real roots. Now, in these two cases, you can see that real roots are there. So that's why if discriminant is either 0 or positive, there is real roots. In the board examinations, the question will be asked that check whether the following quadratic equations have real roots or not. In that case, don't be confused with it. Just find it out the value of d. If the d is equals to 0 also, there exist real roots. If the value of d is positive also, then also we can say the real roots. But for the equality and inequalities, then we have to check the value of d exactly. If it is equals to 0, equal. If it is positive, unequal roots. So these are the basic concepts that we can see from the quadratic equations. Keep learning, keep enjoying. Now in the next classes, we will be discussing about the problems that is directly from the CBSE board examinations, that the problems that already been asked there in the CBSE examinations from the chapter quadratic equation. Keep learning, keep enjoying. More you practice, more you learn. Thank you.